Hello everyone, this side Dr. Nitin Sharma, Associate Professor, Department of Information Technology from Akgec Engineering College. Today I am going to discuss about a topic that is Floyd-Warshall algorithm, or we can say that all pair shortest path. It is a topic from the design analysis and algorithm, and it is basically related for the graph segment. Okay, so next, what is basically the Floyd-Warshall algorithm is? Basically, it is used to find the shortest path between all the vertices in a weighted graph. Okay, so it is basically practically used when there are some sort of cities and you want to find out the shortest path between each city to each other. So you can apply for the Floyd-Warshall algorithm. It is different from other shortest path algorithm by using each vertex as a pivot to determine the shortest path. Like we already discussed earlier, like single shows shortest path. So suppose we are having a 5 vertices, 1, 2, 3, 4, and these are basically connected like this. Okay, so we have to be set one vertex as a pivot element and pivot vertex, and then find the distance from each node. Okay, got my point? So this is basically used in the disguster. So disguster is basically used for the single source shortest path, but this is basically the Floyd-Warshall algorithm, which is used for all pair shortest path. So it can be applied to both directed and undirected graph, but the condition is without negative cycle. If there is a negative cycle, so you cannot able to apply a Floyd-Warshall algorithm. It may be giving the right answer or it may give the wrong answer due to the negative cycle. So this algorithm is basically utilize a dynamic programming concept to store previously computing path for overlapping sub problems. Okay, so it is classified as one of the all pair shortest path algorithm. There are so many all pair shortest path algorithm, but today I am going to discuss about the Floyd-Warshall algorithm. So this algorithm is basically implemented by using the adjacency matrix representation of graph. So we are using here the matrices, like suppose we are having a 4 vertex, so we are using here 4 by 4 matrix. Okay, so this is the way we can ready to solve it and utilize the dynamic programming feature. We stored the previous computing matrices, and after that we can just find out the new matrices after updating the matrices. Okay, now initially we just discuss about the theoretically, like what basically we are going to do in this all pair shortest path. So what is basically the problem? So initially you have to be understand what is the problem. Though the problem is find the shortest path between each pair of vertex of the graph. Okay, so like suppose we are having here 1, 2, 3, 4. So this is basically the graph. There are 4 vertex, and we have to be find out what is the shortest path between either 1 to 2, either 1 to 3, either 1 to 4. Okay, so we can say that either 1 to 2, 3, 4, or 2 to 3, 4, 1. So this is basically the way you can just find out the shortest path between every vertices. Why we use graph? Because this is the problem basically you can solve by using the graph. All the vertices are connected through the edges. Okay, but the condition is it may contain negative edge, but no negative cycle. Edges is basically is having a negative edge. Suppose this is the one, so I can just store here -5. It is okay, but when we create a cycle, suppose this is the 4, this is 6. When we create a cycle, sorry, this is 4, this is 1. So when we create a cycle, so it is basically a negative cycle. Whenever cycle is running, the total weight is always negative. Okay, so edge can be negative, but there is no negative cycle in the graph, so you can apply a Floyd-Warshall algorithm. A representation of a weighted matrix, I told you earlier, I am using here the adjacency matrix to solve this problem. So W is basically representing here weight, and Ij is basically the number of row and column is equal to 0 if I is equal to j. What does that mean? It doesn't mean the diagonally element is always 0. I is equal to say 1 1, that means 0, 2 2, that means 0. What does it mean? It means that a node is having like 2, and if they want to reach 2 to 2, so the cost is 0, the weight is 0. So this is, I am writing here 0. Wij is equal to infinity. The next is, if there is no edge between I to j, for just like in this graph, if I can talk about, there is an edge between, suppose there is a 5 node, okay, so I can connect it here. So there is any directed edge 2 to 5? No. So we can just write here infinity. Okay, I'll explain with the example also, but initially we discuss about some theoretically. Okay, Wij is equal to weighted of the edge. So all the others value in the matrices, we can put what are the weight is written on the edges. Okay, so this is the way you can just create the matrix. We can try to understand with an example. Okay, so what are the steps to solve this problem? So steps is like, first step is you should create a adjacency matrix. So adjacency matrix, suppose you giving a name at W, okay, or A, B, C, whatever you want to give the name, and it will basically represent the cost of edges presented in the graph. But you have to understand the initial two conditions which I discussed earlier. First is Wij is equal to 0, this one, that means the diagonal is always 0, and Wij is equal to infinity if there is no edge between I and j, and otherwise whatever edge, whatever weight is written on the edge, you can just write into the matrix. Okay, so the first step is you have to prepare the matrix, right? Second is derive another adjacency matrix like A1, A2, A3, A4. How many matrices will be created? It is basically created totally depend on the edges. So suppose you are having a 4 edges, so you have to create a 4 matrices A1, A2, A3, A4. Okay, so what is the formula basically? So we have to apply this condition. So suppose we are going to apply a A1ij. So the value of k is 1, because this is basically the k, right? So A of ij is greater than A of ik plus A of kj, then replace Aij with the combination of this one. Okay, I'll explain with an example, exactly example. What basically here they are doing this. The cost is between I to j, and I just find out if there is an edge between of them, like k is the number edge which is basically we are introducing in between of them. So what will happen here? So k is between, so it is going to I to k and then k to j. So this is a path. So if there is a edge which we can use and find out the minimum path, so you can put that value, otherwise you can hold the previous minimum value. Okay, so this is the way you can just update the matrix, and this is the second step is repeatedly until all the matrices has to be covered, right? Like for all the matrices in the graph, by changing the value of k for every pivot vertex, every vertex, until the final matrix is achieved. So it is basically running. Suppose you are having a 4 matrices, so this step is running 4 times. Suppose you are having a 5 matrices, so you are running ahead 5 times. Okay, so it is totally depend on the number of vertices. So whenever graph is giving, you know the value of k. So on the basis of this, you can just write the loop. Okay, and the final step, the final adjacency matrix is obtained the final solution with all the shortest path. So this is the basically we can say that there is only one step, which is the second step, because initially you create the matrices, third one is repeated the second step, and fourth is the final solution. So let's take an example and we try to understand how you can apply a Floyd-Warshall algorithm to the given any graph. Okay, so this is basically, you can see this is a graph. There are 4 vertices and edges are running in every edge. Got my point? So what is the step 1? Step 1 is remove all the self loop and parallel edges. There is no self loop, because I told you earlier self loop is basically the 0. Suppose I can write here, suppose this one is, so this is, suppose they are writing a 6, so this is wrong. We have to be right here 0. So there is any self loop, you have to be remove them. Okay, and you can say that I have already written there is no neither self edge or nor parallel edges here. Okay, so first one is this one. Now we have to write the matrices for the initial graph. Okay, so you can see in this slide, you can see this is the graph and this is the matrix, and you can see how I can write the matrices. So I told you earlier, it is totally depend on total number of vertices. So vertices are 4, so we have to be create a 4 by 4 matrix. Okay, first step. Second is we have to be write a 0 on the diagonal, because if I can write here d I j is equal to 0, this is the step now. If I is equal to j, so where obviously 1 1 2 2 3 3 4 4, right? So these are the diagonal, so I can put diagonal is 0. So this is filled. Got my point? Second is we have to put the direct edges weight. So initially 1 to 4 is 1, so 1 to 4 is 1. Then 1 to 2 is 8, 1 to 2 is 8. 1 to 3, 1 to 3 is nothing. There is no direct connected edge. This is basically 3 to 1, not 1 to 3, right? This is a directed graph, so you have to be measure the direction. So I can see here there is no direction between 1 to 3 directly. So what we have to be write here? Here is infinity. Got my point? Similarly, you can put all the rows. One more row I can take here. For suppose 2. 2's to 1. So 2's to 1 is there is no direct connected edges. So what we have to write here? Infinity. 2 to 3. 2 to 3 is a connected edge, that is 1. So we can write here. 2 to 4. 2 to 4 is there is no connected edge. This one is basically the 4 to 2, not 2 to 4. So we have to be write here infinity. Similarly, you can just take another one like 3 to 1. 3 to 1 is this one. So edge is 4. 3 to 2, 3 to 2, there is no direct connected edge, infinity. 3 to 4, 3 to 4, there is no direct connectivity, that is infinity. Next one 4, 4 to 1 is infinity because there is no direct connection. 4 to 2 is 2 because 4 to 2 is 2. And 4 to 3 is 9. 4 to 3 is 9. So this is the way you can just create the initial matrix. And here I can take the matrix name is D0. So D0 is the initial matrix which we can create it by using the given graph, whatever graph is given. So I can just create it this one. Got my point? Next is you have to create the D1. So this is the way we are just executing the step number 2, and we executing the step number, repeating the step number 2 4 times because we are having here 4 matrices. Got my point? Okay. So how this can be created? So initially when you are taking here first index, okay, first vertex, so first row and first column you can just put as it is, whatever value is in D0 on the from the previous matrix. So this is D1, this is D0, so I can just write 0 8 infinity 1, 0 8 infinity 1, 0 infinity 4 infinity, 0 infinity 4. So I can just write as it is. What we have to do the other one? So other one we have to put a formula like D1. Formula is basically D1, or we have to be suppose get this value. Okay, listen one thing, we have to be check this one value, so you can understand all other things, because this is the value which is basically changing, or this one is changing. So I can just take first one here, okay, because this is the same value. So 3 2, so we can write here 3 2 is equal to minimum of D0 3 2, either you can take this value or D0 3. Now you can put the intermediate value in between of them like 1. So you have to write 3 to 1 plus D0 1 to 2. That one is 2. So either this value or either this value, whatever is minimum, you can just replace that one. Okay, let's try to do this. Minimum D0 3 2. D0 3 2 is infinity. So we can just write here infinity, comma. D0 3 1, 3 1, that is 4, plus D0 1 2, 1 2, that is 8. Okay, so you can easily see that infinity and 12, what is the minimum value? 12. So we can put here 12. Okay, through this we can just going to create a formula which we earlier discussed, One is we can assuming here K, that is Ij is equal to minimum D K minus 1 Ij, comma. Okay, so I am calculating K. So the previous matrix Ij value or D K minus 1 Ik plus D K minus 1 Kj. So this is basically the function which you are calculating repeatedly. Similarly, you can apply on this one by yourself, okay, or anyone like, okay. So I can just take one more. Suppose this one is. So this is basically D1 4 3 is equal to minimum of D0 either 4 3 comma D0 4 2 1 plus D0 1 3, okay, is equal to minimum D043. D043 is basically 9, okay, 9 comma D041. 41 is infinity plus D013 infinity. So which one is minimum? Infinity plus infinity is infinity, either infinity or 9. So we can just put here. So this is the way we are getting here the updated matrix. So this is the basically step 2, which is you are repeating until the you can get the final matrix, okay. Next one. So this is my updated matrix D1, which I getting when we are using one matrix as a intermediate matrix. Now I am talking about a D2. So I am talking about the second vertex. So second row and second column I can take it as it is, okay. So 0 8 infinity, second is infinity 0 1 infinity, infinity 0 1 infinity, 8 0 12 2, 8 0 12 2, and all other things should be updated here. So I can just take one value which is updated here. So this one you can see here, this one value here is 9, here is infinity. So I can just put one value so you can easily understand. So D2 I have to be check 1 comma 3. So is equal to minimum D1 1 3 comma D1 1 and 3, and in between matrix here is 1 and 3, and in between matrix is D2 1 3 is equal to minimum of D1 either 1 3 comma D1 1 2 plus D2 3, okay. So this is the way we can just calculate it here. So is equal to minimum D13. D13 is infinity, comma D12. D12 is 8 plus D23. That is 1. So which one is minimum? Infinity or 9? So we should update it here. So this is the way you can just update it matrix D2. Similarly, you can apply for the D3. So now you can see here I am having here the D2 updated matrix, and now I am going to create the D3. When we are going to update it the D3, the third row and the third column you can just take as it is. So the third column 9103 as it is here, and the 41205 41205. So there is no changes in the third row and third column, and all other things are updated here, okay. So similarly you can see that this one is updated here. So similarly I can just calculate it here that D3 2 1 is equal to, so previously 2 3 is previously 2 1. So previously 2 1 is basically infinity. So which one we have to be taken here, either minimum infinity or in between 2 3, sorry. So 2 to 3. So 2 to 3 is 1. 2 to 3 is 1 plus, and 1 3 to 1. 3 to 1 is 4. So which one is minimum? Infinity or 5? 5. So we have to be updated here. Okay. So similarly, you can update it all the other elements in the matrix is whatever the left it after considering the third row and third column. Okay. Next is 4. So similarly, I am having here the D3, and when we are going to create a D4, so you can see the fourth row and fourth column you can take as it is. Okay, 4th row and 4 column you are taking as it is, and all the other value you should update it here. I'll take here the one example. Okay, so like you can see previously we are having a 12 and here I am having a 7. Okay, so let's see what will happen here. So D4 and I am calculating here 3 2 is equal to minimum of D4, the previous matrix, that is D3, either 3 2 comma D3 and whatever the edge in between 4. So D3 3 4 plus D3 4 2. Okay, so let's take D3 3 2. 3 2 is 12. So is equal to minimum is 12 and D3 3 4 3 4, that is 5 plus D3 4 2, D3 4 2, that is 2. So you can see here this is 12, this is 7. Whatever is minimum is 7. So we can update it this value. Got my point? So this is the way you can update it the matrix of D4. After applying this 4th step until you can get the final matrix, which is I am getting here 4th. This is the final matrix and the answer. So if I am getting the all pair shortest path here, all pair shortest path cost here. So if anybody is asking what is the cost between 4 to 3, so 4 to 3 is cost is 3. What is the minimum or shortest path or cost between 1 to 3? 1 to 3 is 4. 1 to 4, that is 1. Got my point? So this is the way you can just apply Floyd-Warshall algorithm in any graph and you can get the result. Okay, let's do the analysis. As I discussed the formula, this one is basically you can see here. So this is basically the step which is repeating every time. Okay, so we are using basically here 3 loops. So using 3 4 loops, and every loop should running the n times. N means the number of edges time. Okay, so like D4 is calculating. So initially first is basically the loop which is running basically the 4 times, right? Because we are calculating D1 to D4. So this is basically running the 4 times. Okay, and every time you should check the every rows and every columns. Okay, so every row and every column, that means you have to be running that n square times, and this is basically running the n time. So n time. So the total cost is basically coming, the Floyd-Warshall algorithm complexity is n square, where the n is the number of vertices. So you are having suppose n number of vertices, the time complexity of the Floyd-Warshall algorithm is n cube. Either you can calculate it like the Disgastra algorithm, the complexity of Disgastra is n square, and that is basically the n square Disgastra algorithm, and it is applied for the n times because we have to be find out the all pair shortest path, and Disgastra is giving the single shortest path. So when we are applying Disgastra to the n times, so we can get the same result. So we are having here the same complexity here. Okay, so this is the graph and this is the matrix. So this is basically the weighted graph, and there are 5 matrices, and I have written the adjacency matrix here. You can just take the screenshot or you can just pause the video and write down on your copy and solve that. And after that you can just paste your result in the comment box. Okay, and if you have any problem you can just comment on the video. Thank you so much. Thank you.